When we talk about differential calculus, it is mainly centered on the derivative of the function. When we talk about integral calculus, it is all about defining and finding the area bounded by the graph, or it is bounded by the graph of the function. It is centered on area bounded by the graph. So differential calculus centered on derivative, integral calculus centered on area bounded by the graph. So when we find derivative, it is differentiation. When we find antiderivative, it is integration. So when we find antiderivative, it is integration. So the process of finding derivative is differentiation, process of finding antiderivative is integration. So we can call the antiderivative as a primitive function, or we can call that as integration also. So finding antiderivative is a process, and the process is the integration, and it is also called as primitive function, which is primary. So it is nothing but the primary function. So from where the derivative is obtained, that function is primitive function, it is nothing but the primary function. For example, we can take differentiation dy by dx of x square. You will know that when you differentiate x square, you will get 2x. So when we find the antiderivative of 2x, so antiderivative of 2x is x square. So antiderivative is nothing but the inverse of derivative. The derivative is 2x, so inverse of derivative will be the function from where you got the derivative. So antiderivative of 2x is x square. So from here we can say that integration is the inverse of differentiation. Integration is the inverse of differentiation. It's inverse of differentiation. So we can visually, represent that as, if x square is a function and 2x is the derivative. So to get that, you need to differentiate this. And if you want to get 2x to x square, that's integration. So it's an inverse process, and it's an antiderivative. Process of finding antiderivative is the integration. Process of finding derivative is differentiation. So I can represent this, instead of writing antiderivative of 2x, I can represent that as a standard form. 2x dx is equal to x square plus c. So we'll talk about all the new things here. So this is nothing but the summation symbol. So we'll talk about that summation symbol in the introduction of integration in another video. And this c is constant of integration. This c is constant of integration. Why it is constant of integration? So let us take some examples. So if I differentiate x square plus 1, I'll get differentiation of x square is 2x, differentiation of 1 is 0. So dy by dx, x square minus 1, again you will get 2x. Differentiation of x square is 2x and differentiation of negative 1 is 0. So if I differentiate another function x square plus 4, I'll get 2x. If you differentiate a constant, your answer will be 0, so you're adding that, so you will get 2x. So for all these functions, the derivative is 2x. We may not know if I integrate this 2x, we may not know the constant which was there. So it can be any number, even it can be 0. So we are representing that constant as c, and when we integrate that, we are getting the c. That's why it's constant of integration. There are two types of problems in integral calculus. One is finding the function when derivative is given. Finding function when derivative is given. So that's what we have seen before. So 2x is the derivative. And we got x square plus 1. X square can be x square plus 1 or x square minus 1 or x square plus 4. So that's why we have written using c, x square plus c. And another problem is finding area bounded by the graph. Finding the area bounded by the graph of a function. So if I have dy by dx and the function is x square and 2x is the derivative, if I know the derivative, with some formulas we can find the function. So for example, integration of 2x with respect to dx, you will get x square plus c. So we'll come to that formula later. And finding this area, if I have a curve like this and I need to find area under the curve x, y, for example, if I take this as 0 and 4, if I want to find the area between 2 and 4, so we can find integration. We can find the area between 2 and 4 under the graph by using integration. So these are the two problems we can use integration. There are two forms of integrals. One is definite, another is indefinite. Definite integral, it follows the limit or it follows some condition to find the area bounded by the graph. So it's defining the limits. An indefinite integral, there are no conditions and we will get family of curves in integrations. So we'll see how we can get the family of curves. We can take the same example, dy by dx x square. So if you differentiate, you will get 2x. So if you integrate 2x with respect to dx, you will get x square plus c. So we have seen that it can be x square plus 1, or it can be x square minus 1, it can be x square plus 4, or it can be x square plus or minus 4. It can be anything. So if I sketch the graph, so this is x square plus 1, this is x square minus 1, this is x square minus 4, this is x square plus 4. So everything, the shapes are same, all the shapes are same, but only the y-intercept, only the point of intersection on y-axis is different. And we call this as family of curves. So we don't know the constant c. If you know the constant c, you may get the family of curves, different curves. It depends on the constant c. It depends on the constant c. We'll talk about some basics of integration. So this summation of f of x dx, we can read that as integral of f with respect to x. Integral of f with respect to x. And here f of x in integral of f with respect to dx is integrand. And x in f of x dx is variable of integration. So with respect to what you are integrating. So integrate means find the integral. So if you integrate a function, you will get integral. If you differentiate a function, you will get derivative. And integral of f. Integral of f, a function f such that derivative of fx is equal to f of x. So we'll talk about that property later. What is integration? A process of finding the integral is the integration. What is constant of integration? Any real number c consider as constant of integration. So the real number, which means it should be on y-axis. So that's why it's real number. We have seen that geometric representation. So now we'll move on to properties. So we have 5 properties. This is the first property. The process of differentiation and integration are inverses of each other. So we know that. So when I differentiate the integrated yet to integrate, I'll get the same function. Differentiation and the integration are inverse to each other, so they cancel each other. For example, the same problem, we will get 2x dx. So integration of 2x, integration of 2x will be x square plus c. We have already seen that. And if you differentiate this, you will get 2x, and if you differentiate the constant, you will get 0. So finally we have arrived what we have started. So this is one property. And if you integrate the derivative, you will get the function. So this already we have seen that. So if we are like dy by dx of x square is 2x. So 2x is the derivative. So integrate 2x, you will get x square plus c. So 2x is the derivative and x square is the function. So this is first property. Second property, two indefinite integrals with the same derivative lead to the same family of curves and so they are equivalent. We'll prove this property with an example. So dy by dx, x square plus 1 you will get 2x, and dy by dx, x square plus 2 is equal to 2x. So if we integrate again, if you integrate this 2x, you will get x square plus c, here also x square plus c. So these two integrals has same derivative. Okay, this is derivative, this is integral. Two indefinite integrals with same derivative leads to the same family of curves. So this is family of curves. Hence, we can say this as integration of f of x is equal to integration of g of x. So this we can take this as f of x, we can take this as g of x, and they are equivalent. So third property, so if I want to integrate two functions which are added, I can integrate separately also. Both will give me the same answer. Okay, let us take some example for this. Some examples. Let us take one example for this. So before that, we should know a formula. So we'll talk about formulas in part 2 of this introduction. So if I have x to the power n as integrand, so if I want to integrate x to the power n with respect to dx, I'll get the answer as x to the power n plus 1 divided by n plus 1 plus c. So we'll discuss this formula. We'll discuss this formula in part 2 of this video. So if I have, for example, if I have x square plus 2x square, so if I integrate x square, so if I can simplify this as 3x square dx, and if I integrate that, so we can apply this formula. I have 2 as n, so 2 plus 1 divided by 2 plus 1. So I'll get 3x to the power 3 divided by 3, and you will get x to the power 3 as answer. So this is the LHS. So we'll move on to the right hand side. So integration of x square dx plus integration of 2x square with respect to dx or with respect to x. So you will get x cube by 3 plus x cube by 3. So you will get same base, so we can add the numerator. So 3x cube by 3, so you will get the answer as x cube. So right hand side. So hence proved. Left hand side is equal to right hand side. So I can integrate by simplifying the expressions first, or I can integrate the terms separately. I'll get the same answer. This is one of the properties. So fourth property. If I have a constant k and that's a real number, I can take out the constant and I'll get the same answer. For example, two x square dx will be same as 2 into integration of x square with respect to x. So if I integrate this, so x cube by 3 dx, if I integrate this, x cube by 3, sorry, here you will not get dx, so which can be simplified as x cube by 3, here also 2x cube by 3, so they are same. So I can remove the constant, then integrate the function, I'll end up with the same answer. Finally, I can combine the property of third and fourth and write it as one expression. For example, if I have constant and all the functions are written as one expression, then I can write separately also. So I can integrate separately, I'll end up with the same answer. K2 f of x d of x. So this is f function, f1, f2, this is nth function. So I'll get the same answer. So we have seen what is integration. So integration is a process of finding antiderivative. It is a process of finding antiderivative. Process of finding derivative is differentiation. Process of finding antiderivative is integration. And we have seen the representation of integration. So this is integration of 2x with respect to x. And we have seen the types of integral calculus: finding function with derivatives given, finding area bounded by the graph of the function. So two forms of definite integrals, indefinite integrals. Definite integrals, there will be conditions or limits. So with that we can find area. Indefinite integrals, there are no conditions. So you will end up with the family of curves. So we have seen the basics of integration and we have seen 5 properties. So we have seen 5 properties. That's all about part 1. Thank you.